Hello, this is section 3.2, which is talking about addition and subtraction of whole numbers. Now, before we get into any of this, because addition and subtraction of whole numbers, of course, should be review. We all know how to add and subtract, but there are just a few things that I want to point out. Especially, we're going to go over some properties that you need to know. But also, I would like for you to read the section 3.2, especially because it does give some different approaches to teaching addition and subtraction, and that I'm not going to really go over. But they talk about a method called counting on, where children, where you can start at a number and then count so many more in order to add. They talk about a set model, which is their formal way of talking about really the way that children first learn how to add, which is, if so and so has two cars and so has three cars, then how many cars do they have together? And you're using little models to show that. So that's actually called set model approach. There's also a number line model that you can read about, and then there are some kind of they list out um, some kind of tricks sort of to addition. They talk about, kind of creating groups of 10 and things like that, which, well, I'll keep going. Anyway, and then they give you some subtraction ideas that talk about like the takeaway model, where you would have, like five cars sitting on a table, and you would take two of them away and see how many are left. They also talk about the missing add-in model, and fact families that I would like for you guys to read about. And also just some interesting things. There are some historical notes on page 100 and 101 that talk about how we derived zero, where it came from, and then also where the symbols plus and minus came from. So they weren't just born into nature. Somebody had to come up with them. So those are kind of interesting things to know, especially, as you're going to be teaching this. So I would highly recommend, and don't forget, you can read this on your computer. You don't have to have a hard copy of the textbook. Just go to the online textbook and read through this section. Just kind of peruse it. I kind of am not going to make a big deal about each method or model of addition and subtraction. I think that once you get into a classroom and you start teaching, you're really going to have to assess what's going to be the best approach for these students. But then also, I think you need to keep in mind very carefully that you don't want to create a situation where the students can only add by using models and by using like base 10 blocks and things like that. You want to kind of give them those to play with and to show them the idea of what's going on, but then knowing their basic facts by memory is crucial. So they've got to know those, otherwise they'll never be able to progress on to algebra. So just keep in mind that, all of the gimmicks and all of the shortcuts and all of that stuff are great and fine. They have their place, but it cannot replace good old-fashioned memorization and drills. Drilling students to where they know their addition facts backwards and forwards. Okay, so let's get started with this. The first thing that I really want you guys to know are the proper terminology for things that you're adding together. So for proper terminology, When you add two things together, those things are the add-ins. So an add-in plus an add-in equals a sum. So those are the proper names for each of those things. So for instance, if I were going to do 2 plus 3 equals 5, then 2 would be called an add-in, 3 would be called an add-in, and 5 would be called the sum. So I want you to know that. Those are very important. There are also properties that allow us to be able to do addition. And even though you probably won't be teaching this, it's important for you to know how and why it is that you can add. So, I mean, you might very well run into a very bright student that starts asking you all the why questions. So you do need to know that. First of all, we're talking about the whole number set now, which, if you'll remember, before we were working with the natural numbers, and those are the natural numbers are the set that starts with 1 and then goes to 2, 3, 4. Sometimes it's called the counting numbers. When you add 0 to that set, it becomes known as the whole numbers. Oops, I need the whole numbers, my highlighter there. Okay, so the first property that deals with addition of whole numbers is called the closure property. And the closure property tells us that the whole numbers are what we call closed under addition. Now, this means that it doesn't matter what two numbers you pick in the whole number set, the whatever your answer is also in the set. There's nothing that appears outside of that set. So any two numbers that you add together is going to be a whole number, which would be in the whole number set. That's what makes it closed. Now, on the reverse of that, subtraction is not closed, because if you were to do, like, say, let's do 5 minus 6. That would be a -1, right? -1 is not a whole number. It's an integer. So you can't take two whole numbers and subtract them and always get a whole number. So that's why subtraction is not closed, only addition. Then we have the commutative property of addition. And the commutative property, it's a way of telling us that we can add in any order we want to. So for instance, 3 plus 8 is the same thing as 8 plus 3. Then we have the associative property of addition. And again, this is still talking about being able to add in any order you want to. But I want you to notice that in the associative property, the order of things do not change. We still have 3 plus 6 plus 8, 3 plus 6 plus 8, but we are reassociating. So we're telling it or forcing it, because you have to do parentheses first according to order of operations. So we're reordering what we're doing first by using parentheses. So the way that I keep these straight is I think about the words commutative and associative. And the very first part of the word commutative is commute. So like your commute is, going back and forth to work. So you go from, home to work and work to home, backwards and forwards. So the order changes specifically. With the associative property, you think about the word associative, and you're reassociating the items. So these are not in a different order, but you are reassociating them with parentheses, forcing you to have to add them differently because of order of operations. And then finally, we need to talk about the identity property of addition. And if you read through the textbook in this section, they also talk about the inverse property of addition. The inverse property they talk about being subtraction. So inverses, we kind of think of undoing things, so or going backwards. So it is true that subtraction goes backwards from addition. However, this is really not the best definition of inverse properties. And so I wish they had not put it in the book and put it quite like that. Um, just because um, it's better to say that inverses are what you do to get the identity. And it's much better for students to learn those types of higher level things once they get positive and negative numbers under their belt. Because then you can talk about positive and negative numbers being inverses of each other rather than just addition and subtraction. Because, well, technically, there is no such thing as subtraction. All you're doing is, combining or adding positive and negative numbers. But the problem with that concept is that small children have no way of comprehending that. Their brains are not formed enough yet to be able to do any sort of hypothetical thinking. They are very, very concrete at that stage. It's only what they can see and touch and feel and smell, and they need concrete examples. That's why we start out teaching subtraction, even though technically there is no such thing. The only thing technically that there is addition, and everything comes from that. So multiplication is just a shortcut to addition. So it's very interesting, but there's no way you can explain that to a 6 or 7 year old. They can't comprehend that kind of abstract thinking. So I think that it would be best if you can all get away from it to not talk about inverse properties in this context, because I think that it gives small children, first of all, more vocabulary that they have to learn, and second of all, it gives a little bit of um, a false idea that then they have to unlearn later, and so that could become problematic. Anyway, but once you do understand about inverses, and you know that positive and negative numbers are inverses of each other because they give you what's called the identity. And in addition, 0 is the additive identity. Think about the word identity. Identity is, if you think about your identity does not change depending on where you are. If you're at school or at home or whatever, now your roles change. The expectations that are put on you change, but those are different from your identity. Who you are doesn't change depending on your situation, your physical situation or your dress or whatever. Who you are is always the same. So the identity is what you do, and it doesn't change a number. So for addition, it would be the thing that you would add to a number, and it doesn't change it. So that's why 0 is the additive identity. So that's called the identity property of addition. So that says that there exists a number that when added to any number, it doesn't change that number. For addition, the identity is 0. When you add 0 to any number, it does not change. So 0 is called the additive identity. Now then, once you understand that, then it makes the idea of inverses a little bit more clear, because inverses are what you do to get the identity. So, like 5 minus 5 would give you the identity of 0. So that's why they talk about it in this section, even though they probably should wait until students are of an age to be able to pick up positive and negative numbers. Okay, so here again, just to kind of reiterate, this section's been all about addition, and all of these properties that we've been talking about. Nowhere at all did we talk about a commutative property, an associative property of subtraction. We talked about them only in reference to addition. Technically that's because there is no such thing as subtraction. Our minds, we're trained from a young age to think that there is, just because we simply cannot comprehend the idea of a negative number at that early age. So this is something that we do have to incorporate into our already knowledge base as we get older. And I think that sometimes we don't do a very good job of replacing that previously held notion with new ideas. So I just want you to always keep that in mind as you're teaching this, so that maybe you can be aware of it enough that it will make your teaching approach a little bit easier for students to understand. Also, I think that it's very important that you know all the pieces of a subtraction problem, because they do have specific names. The first number is called the minuend, and the second number is called the subtrahend, and then the outcome, or the equals part, is called the difference. So for instance, if I had 5 minus 3 equals 2, 5 would be the minuend, 3 would be the subtrahend, and 2 would be called the difference. And again, if you kind of peruse through the section in your textbook, it kind of gives you the Latin. Well, I don't remember if it gives you the Latin, or if I found it on a website. But you can always go and type in minuend and subtrahend in Google, and it will give you the derivation of where those things come from.